is an introduction to stoichiometry. So we've learned how to balance equations and learned how to predict what products are going to be formed. Stoichiometry is about predicting if we have the mass of the reactants, we can figure out the amount of the product we're going to form. So stoichiometry is mass relationship between reactants and products in a chemical reaction. Now, one important conversion factor that we're going to look at is mole ratio. This is the easiest conversion factor to find. It relates the moles of one compound to the moles of another. You must have a balanced equation in order to get mole ratio, because that's where it comes from. So the formation of water is this reaction. This is one I'm going to use for all of my examples in this podcast. So hydrogen gas, lighting it on fire, you're going to get water vapor. That equation is balanced, and that is the first step, almost a compulsion that you're going to have when you're working with equations. So those coefficients make up your mole ratio. What this reaction tells me is that it takes two H2s reacting with one. Now this is an understood one, just like 1x. It's just written as x. And so two hydrogens are going to react with two oxygens to form two water molecules. And we can write that formally like this. So those numbers there with the 2 moles of H2 come from the coefficient in front of H2. Now notice it is just the coefficient. You don't deal with subscripts when you're looking at mole ratio. Okay, the other conversion factor that we'll be working with is molar mass. Now, molar mass is how we go from grams to moles and moles to grams. Now, this should be a review. Molar mass of hydrogens, 1.01 grams per mole, and that's from the periodic table. The molar mass of oxygen, 16 grams per mole, and again, that's from the periodic table. So, in dealing with the equation that I have up here, this formation of water, I can find the molar mass of several different things in there. The molar mass of H2 is 2 times 1.01, and that's because of the subscript. Now, coefficients have nothing to do with molar mass. Because there is H2, it's 2 times 1.01 to give you that 2.02 as its molar mass. Then we have oxygen, and it's O2, so it's 2 times 16, and that's 32. And then the molar mass of water, we have 2 hydrogens and 1 oxygen, adding up to that molar mass of 18.02. Okay, those are the 2 molar masses we're going to work with. So now let's look at some of those conversions. I have some steps necessary for these conversions. Number 1 is balance the equation. Never try and do a stoichiometry problem before you've balanced the equation. That is necessary. That's where your mole ratio comes from. So find your mole ratio from that balanced equation. And then find the molar mass if you're going from grams to moles or moles to grams. Then it's dimensional analysis. Always start with what's given in the problem. Okay, so let's start working with some of these problems. The first problem we're going to look at is a mole-mole calculation. We're going to use mole ratio in this one. We're going to go from moles of one compound to moles of another. So here's our example problem. And we'll get this up here so that I can work some. All right. Now, it would come with a chemical equation, which is the formation of water. I told you that's the one I'm going to use for all of my examples. Start with a balanced equation, so we need to have a 2 here and a 2 here. Then we're going to draw a map. So we're going to take the information that we need out of this problem and out of this word problem so that we can see what we have and where we're going. So it says, how many moles of hydrogen? Well, hydrogen is this H2, so I'm going to write question mark moles. That's what we want to find out. Now, water over here does contain hydrogen, but they're not talking about water. If they say moles of hydrogen, they're just talking about that hydrogen. All right, would be required to form 5 moles of water. So I have 5 moles of water. All right, like I said, I'm going to call this your map. Balanced equation with where you're starting from and where you're going. Now we're going to start a dimensional analysis problem. And we start 5 moles of water. Make sure you put your identifiers in here because now we're going to start moving around in the chemical equation. At this point, with every stoichiometry problem, you're going to ask yourself the same question. Can I use mole ratio? If you have moles right here, the answer is yes. So, can we use mole ratio? Yes, because we have moles there. So moles of water are there on top, so moles of water have to go down here so they'll cancel out. And with mole ratio, it's always moles of what you had at that beginning spot under moles of where you're going to, or moles of where the question mark is, and that's H2. Now you're going to fill in the numbers, because right now I just dealt with the units. We're going to fill in the numbers. Mole ratio comes from the coefficients. So my moles of water are 2 from the balanced equation. That's its coefficient. And then moles of hydrogen, its coefficient is 2. They happen to be the same. That won't always be the case. Now moles of water cancel out, and all I'm left with are moles of hydrogen. Write down those units so I don't miss any points. And then my answer with 2 sig figs, because that's what I started with. 5 moles of hydrogen is required to form 5 moles of water. And that's the very basic type of stoichiometry problem. We're going to build from this with these other problems. Okay, this is a problem that I had in my class work. With this one, I'd like for you to try it. So go ahead and pause the podcast and try and give this one a shot. Right, now I'm going to give the answer, so if you haven't worked this problem, go ahead and work it. I need to first balance my reaction. So I have 2 oxygens on the reactant side. I only have 1 on the product side, so I need 2 there. And then I have now 4 lithiums on the product side, so I need a 4 here. Now, how many moles of lithium oxide, so question mark moles, will form 2 moles of lithium. So I have 2 moles of lithium. Start with the number they give you in the problem, 2 moles of lithium. Can I use mole ratio? Yes. So moles of lithium are here. So moles of lithium have to go here. And under moles of lithium oxide. Okay, because that's where the question mark is. Then I fill it in with the coefficients. Moles of lithium, the coefficient for lithium is 4. And moles of lithium oxide, the coefficient for lithium oxide is 2. Moles of lithium cancel out, and I'm left with moles of lithium oxide, which is what they wanted, and the answer here is 1, keeping with the same number of sig figs. Okay, problem number 2. Again, this is one that I would like for you to work. Go ahead and pause the podcast and make sure you can do this one. Now I'm going to go through the answer on how to find the moles of potassium chlorate. Make sure you read these correctly. First thing I need to do is balance the equation. I need to get 6 oxygens on each side, so that balances that equation. How many moles of potassium chlorate? This is potassium chlorate. This guy over here is potassium chloride. Make sure you read all the way to the end of the formula. Are needed to produce 15 moles of oxygen. So 15 moles of oxygen. Start with the number they give you in the problem, 15 moles of O2. And you ask yourself, can I use mole ratio? Because I have moles here, the answer is yes. So do. Moles of oxygen go down here. And then moles of where the question mark is goes on top, KClO3. Then fill them in with the coefficients. The coefficient of oxygen is 3. The coefficient of potassium chlorate is 2. Moles of oxygen cancel out. And I am just left with moles of potassium chlorate. And when I do everything on top multiplied together, divided by everything on the bottom multiplied together, I get 10. That only has 1 sig fig, and I need 2, therefore my 15. So to do that, I just need a decimal point there. That gives me 2 sig figs. Okay, hopefully by now you feel pretty comfortable with using mole ratio. Now we're just going to expand out our stoichiometry problems. So our next one is going to be a mole mass calculation. We're going to use mole ratio and molar mass. We're going to go from moles of one compound to mass of another. And mass is going to be in grams. All right. So how many grams of hydrogen, so question mark grams, I already have a balanced equation here, will be required to form 5 moles of water, 5.00 moles of water. So I write down 5.00 moles of water And I ask myself that same question, can I use mole ratio? Because I have moles here, the answer is yes. So do moles H2O, and I'm going to moles of hydrogen. It has to be moles because this is mole ratio. Then I fill it in with the coefficients. The coefficient of water is 2, and the coefficient for H2 is 2. Moles of water cancel out. Now I have moles of hydrogen, but they don't want moles of hydrogen. They want grams of hydrogen. So to go from moles to grams, we're going to use molar mass. Now we just want the molar mass of H2. That's 2 hydrogens. So if you look on the periodic table, that's 2.02. Well, it's actually 2 hydrogens times 1.01. We did this before. Equals that 2.02 grams per mole. Mole is here. So mole has to go here, and in 1 mole, there are 2.02 grams of hydrogen. Moles cancel out, and all we're left with are grams of hydrogen. I have 3 sig figs given to me in the problem, so my answer needs to have 3 sig figs. Everything on top multiplied together divided by everything on the bottom multiplied together, and I get 10.1 grams of hydrogen. Next, we're going to do mass mole calculation. So we're going to go from mass of one compound to moles of another. And we follow the same process. How many moles of hydrogen? So question mark moles. Draw our map. Are required to form 5 grams of water, so 5.0 grams. Start dimensional analysis with the number they give me in the problem, 5 grams of water. Can I use mole ratio? The answer here is no. I have grams here, but I don't have moles. So we have to get it to moles because mole ratio is the only way to move around in a chemical reaction. We cannot move from one thing to another without going through mole ratio. So I know from my knowledge I can go from grams to moles through molar mass. And if I have moles, then I can use mole ratio. So let's go ahead and do that. The molar mass of water, it's 2 hydrogens and 1 oxygen. So that's 1.01 for hydrogen on the periodic table, 16 for oxygen. So water is 18.02 grams per mole. Gram is here, so gram has to go here. And there are 18.02 grams in 1 mole of water. Now, can I use mole ratio? Yes, because now I have moles here. So moles of water, and then moles of hydrogen, where I need to go, where the question mark is. And fill it in with the coefficients. The coefficient for water is 2. The coefficient for hydrogen is 2. Now, all I have is moles of hydrogen, and that is exactly what we wanted. And for this one, it needs to be everything on top multiplied together, divided by everything on the bottom multiplied together. You need to do that if you're doing it in one fatal swoop on your calculator. It needs to be in 1 set of parentheses, not 2, 1 set of parentheses. And so in this case, I think you're going to end up with 0.28. Because we do need those 2 sig figs since that's what we started with in the problem. Okay. Next is going to be mass calculation. This is as far as it's going to go. This is the most practical type because this is what you'd actually see in a real life situation. So, how many grams of hydrogen, so question mark grams, would be required to form 5 grams of water? That's our map. Now we're going to start with the number they give us in the problem, 5 grams of water. And we go through that same process. Can I use mole ratio? No, because I have grams here, not moles. So we need to take grams to moles so that we can use mole ratio because mole ratio is the only way to move around in a chemical reaction. So the molar mass of water is 18.02 grams. Since grams is here, grams have to go here in 1 mole of water. Grams cancel out. Now I have moles. Can I use mole ratio? Yes, because moles are here. So do moles of water to moles of where the question mark is. In this case is hydrogen. Fill it in with the coefficients. The coefficient for water is 2. The coefficient for hydrogen is 2. Moles of water cancel out. Now I have moles of hydrogen, but they don't want moles of hydrogen, they want grams of hydrogen. So then we need to take it to grams using molar mass. So the molar mass of hydrogen is 2.02 grams per mole, and mole is here, so mole has to go here, and in 1 mole there are 2.02 grams of hydrogen. Moles cancel out, and all I'm left with are grams of hydrogen, and it's everything on top multiplied together divided by everything on the bottom multiplied together. Again, if you're going to do it in one fell swoop on your calculator, it needs to be in one set of parentheses because it will follow order of operations, and you should get to 2 sig figs, since that's what I was given in the problem, 0.56 grams of hydrogen. Now, as we're doing this, don't mix your conversion factors. When you have molar mass, like here, water is 18.02 grams in 1 mole of water. And it is always, when you do molar mass, it's that many grams in 1 mole. Okay, so that 1 doesn't change. You're only going to use your coefficients in mole ratio. That's where you get to change compounds. Here we went from water to hydrogen. All right, and this is the only time you use those coefficients. They do not come into the calculation of molar mass at all. This is the only time you use those coefficients. And then over here, again, we're using molar mass, so it's grams over 1 mole, always.